All right. Hi, everybody. My name is Shubhie Panicker. I lead a team at Google that is focused on bringing great user experiences in the web ecosystem by investments in the open source tools and frameworks.
And hi, everyone. My name is Houssein. I work in developer relations at Google. I work with Shubhie, and I focus on frameworks and performance.
So our talk today is about our journey in the React ecosystem and specifically with Next.js. But I want to start with an intro with Chrome's journey in the ecosystem. So Chrome and Google and browsers in general have done a lot of great work in the web ecosystem. There have been terrific advances in standards, incredible improvements in browser engines, and really great strides in documentation and tooling with DevTools and Lighthouse. So stepping back though, in spite of all this, we found that it's still really hard to make big improvements in real production websites at scale. So let's take the example of loading performance. There have been great strides in technology, everything from H2, H3, preload, pre-connect, APIs, new image formats, browser optimizations. So why is it so hard to move the needle? And did we miss something? So this led us to a key insight that we've had through Chrome's journey here. There's a really important piece in this puzzle that we missed. And to truly have sizable impact on real websites, we have to consider developers' actual tooling. And this is a really important point of leverage as it's foundational to how sites are built and the outcomes produced for users of the web. So this led us down the path of collaborating with popular open source tools that power the modern web tech stack. And this helps us maximize our leverage and reach. And this foundational tech stack includes everything from NPM, Webpack, Babel, TypeScript, and a number of other tools that together power a very large part of the web. And in particular, we started with React as the framework because it is the most widely adopted framework by real production sites. And no matter which metrics we use to measure adoption across frameworks, whether it's Chrome page loads or browser time spent or number of deployed production URLs, React was by far most dominant and stable. And since our goal is to reach the widest audience, React is the natural choice to start. And I've had actually a personal journey here in the last year, starting from, why are React sites missing the mark on performance? What's wrong? Is React like driving a poor performance culture? And going from there to realizing, well, that's not really true. And in fact, it's the wrong way to look at this. And further realizing that, wow, production loading performance is still a really hard problem. And in fact, most of the problems we have seen, and we've dug into this a lot in the last year, they're all very similar problems to what I saw 8 or 7 years ago working on Google websites internally with Google frameworks. These frameworks power lots of Google properties, everything from image search to photos. And it was all too familiar a problem. And it's not that developers are lazy or negligent. It's just a natural state of least resistance that I found at Google. And I believe the same applies to the React ecosystem. In terms of what is this problem, we're still juggling with relative priority of fonts, CSS, images, JavaScript. We're still struggling to effectively deliver these assets at just the right time, but fully utilizing the network and CPU. We're still struggling to load more than 10 or 20 resources in parallel without paying a big perf penalty. And efficiently and incrementally delivering JavaScript is still largely unsolved in the ecosystem. And at the heart of this loading problem is really a scheduling problem of ordering, prioritization, and pipelining. And I'll give the example of these metrics. first contentful paint, largest contentful paint, first input delay. It's important to optimize for these metrics in the correct order, like first FCP, then the next metric, which is LCP, and so on. Assets have to be staggered so that they're ready by the time that metric should trigger based on user expectation. And this means figuring out which assets are most relevant to which metrics and ordering them correctly, starting with critical fonts, critical CSS, hero image, followed by JavaScript. Pipelining is really important. By the time first contentful fires, the hero image should be downloaded and ready to go to fire largest contentful paint. And utilization is a really important theme here as well. I often see dead time on the CPU while being network bound, and similarly on the network while being CPU bound. And so good pipelining is really important to keep both the network and the CPU fully utilized. So stepping back, on one hand, it's sort of a sad thought that this is a very familiar problem, and in spite of strides and advancements, we are still struggling with the same things. But on another side of this coin is that it is a similar opportunity. And so this led us down the road of, we have solved very similar problems internally at Google, and we can leverage a lot from that same playbook to solve problems in the React ecosystem. So I'm going to start with just sharing a few points out of that playbook, key aspects, starting with the power of good defaults and opinionated tooling. We think this is the underpinning of a strong tooling foundation. So we have to start here. And this kind of goes to this concept of a wrapper framework, an end-to-end system that we can use to control every aspect from getting started, everyday development to deployment. And this gives us agency over UX and DX by controlling server and client, the build and serve, as well as the production and the development environments. And this is a core premise of our work in this space, that we need to leverage the power of these wrapper end-to-end frameworks to enable developers to successfully build and maintain high-quality production web apps. And very concretely, what this means is that we've been working with Next.js as that end-to-end system. It was a great starting point with a lot of opinions and good DX. And we think we can further evolve it in the direction of this end-to-end system with strong defaults and an opinionated tooling system. The second lesson is learned a little bit the hard way. I would say at Google, we had the benefit of working deeply for years with Google Apps and knowing their systems and their problems deeply and having full knowledge and end-to-end insight and access to the whole system. And this meant we could easily reason about the solutions and designs and what works and doesn't work. And this was a bit of a journey for us in the React ecosystem. And we learned the hard way that we had to rely on real production apps and certainly not use simplistic apps as a replacement. And this is really critical to ensuring that we build the right features for moving specific metrics as intended. This helps us avoid wasting time and engineering work. And ultimately, this is how we identify both the challenges as well as validate solutions. And this is roughly where we ended up process-wise, starting from tracing, which is a really powerful tool from the Chrome engineer's playbook. This helps us deeply get insights on what's going on in real sites, identify the biggest problems and the biggest opportunities. And once we have an idea of that, then we can generate ideas for features and solutions and quickly lab test them with real production sites. And if that looks promising, then we move on to deploying those features, typically behind a flag on these sites. And once we see that stable in production and actually still showing the same metrics improvements, then we feel confident to enable these features by default in Next.js. So to summarize, it comes down to this 4-step of starting with identifying root causes of problems, developing opinionated features, and then baking in these features as defaults, and ultimately locking in these defaults with what we call a conformance system, which is a layer of guardrails that ensures that these features are used and that they are used correctly. So with that, I'm going to hand off to Houssein.
So for the rest of this talk, we'll go over a bunch of features that we've managed to bake into Next.js as part of our collaboration, beginning with Google font optimizations. Font loading can be tricky, and if we're not careful, other low-priority resources could easily interfere with the external font style sheets and files that we load. We added a feature to grab the content of the style sheet when a Google font is detected and inline it directly in the HTML. This eliminates the round trip the browser has to make to fetch font declaration, improving first paint times like the largest contentful paint on a page. By combining that with preloading the font file and ensuring the font only gets inline during render time, this also has the benefit of minimally impacting build times as well as time to first byte. This feature has already shipped and landed in Next.js, and although it only does this for Google Fonts at the moment, we have plans to extend it to include other font providers in the future. To continue on the topic of preloading critical assets, we made sure to do this for critical fonts, but also for critical CSS files, and we've also added a heuristic to identify early important images, including largest contentful paint contenders like a hero image. Although for the latter, we haven't defaulted that behavior just yet. Now, moving on to another really important aspect of building web apps, and something I think we can all agree on that we've needed to do in the past, and that's loading third-party scripts. Unfortunately, there's no easy way to load third-party scripts without affecting the critical rendering path. In other words, what if there was a simpler way to control when exactly third-party resources are downloaded during page load? So we worked on just the thing for that, a script loader component. The script loader was made for anyone to be able to handle loading of any scripts outside of the context of Next.js. And this was done by providing 4 different loading priorities. Lazy, which ensures all other resources are prioritized first. In essence, this script would be lazy loaded. Defer, which means all first-party scripts are loaded first. Eager, which prioritizes this script before any first-party script. And dangerous render blocking, which defaults to the same behavior as before of just inserting a regular script tag in a component. By providing these options, we hope that developers will now have an easier time to control when third parties are loaded in their application. This feature hasn't shipped yet and is still in design stages, however. Moving on to another feature that we've recently worked on, a custom image component to improve both performance and the developer experience of adding images on a site. The API behind this component was made to be intuitive as possible, as well as easy to refactor into existing applications, and it also bakes in a bunch of features by default, including better CDN support, enforced sizing, automatic preload and pre-connect where appropriate, and even plans to integrate automated image optimization. The amazing thing about the last point here is that by incorporating a best-in-class image component, we can make sure that images get optimized right out of the box with no additional work needed. If you're interested in hearing more about this specific feature, Alex, the engineer behind it, is giving a talk at Next.js Conf, so highly recommend tuning in for that. Another feature that we worked on was automatically identifying and inlining critical CSS at serving time. The approach we took here was loosely based on the same technique Critters uses. Critters is a third-party library that anyone can use to incorporate this technique on their site, but we wanted to have that behavior baked into Next.js without the additional overhead of plugging in an entirely different library. This feature is in review stages and should be landing soon. And another major feature, which we've baked into Next.js, that Shubhie kind of mentioned already, is a conformance model to generate warnings for many common issues that developers run into during development. The key idea here is that this all happens during authoring time, letting developers know they've ran into some issues that they should quickly address before shipping their site to production. And we did this by incorporating two separate plugins directly into your workflow, beginning with an ESLint plugin. It enforces usage of next link to prevent accidental full page refreshes during navigation, checks for an optimal fetching of external style sheets, and even warns you if you're missing preloads, as well as if you have unnecessary polyfills or synchronous scripts on the page. We also wanted to build a conformance system around the build process. And so we built a Webpack plugin for this. With this, developers are warned if they decide to modify their default chunking strategy into something suboptimal, or have their minification disabled, or even if general configuration settings seem off. These plugins have both shipped and landed in Next.js. Now, switching gears a bit to talk about rendering patterns. Next.js's capability of static generation is great for pages built that are fully static. However, many sites are not really fully static, even though they may seem that way at first. For example, usage of cookies, specific logic state, and so on. Many of these features are essential for business reasons, and you can think of commerce sites as an example of pages that would incorporate it. In short, static generation is a perfect fit for pages that are entirely static, but be wary of attempting to use it as a fallback if there are dynamic elements on the page. There are many talks in this conference that are undoubtedly diving into static generation and server rendering, so we're not going to go into too much detail here. However, we are actively working on improving the performance of server rendering in Next.js with the ability to flush an early chunk for faster time to first byte. So keep an eye out for this. We've also been using Next.js as a test bed of sorts to experiment with React's new concurrent mode feature. The new Facebook website is built on top of concurrent mode and has been in production at Facebook for over a year. The React team is not yet releasing it in open source because there are still a few significant remaining breaking changes, and they don't want to churn the community before there's a version they can commit to supporting. Concurrent mode will be a part of the initial React 18 release. React also wants to provide a solution for data fetching that, just like React itself, scales from relatively simple apps to thousands of components. They started with the suspense component, which provides declarative loading states, and shipped it in 2018. They're currently working on a solution that is inspired both by performance and composition characteristics of Facebook's GraphQL client, Relay, and the simple and unassuming spirit of getInitialProps pioneered by Next.js. Although suspense itself will be supported in the first React 18 release as a low-level primitive, this holistic data fetching solution, which won't require GraphQL, is in the active experimentation and testing phase at Facebook, and will likely arrive at some point during the React 18x release cycle. Now, the exact number may change, but React 18 is the plan. In the meantime, we've been experimenting with testing concurrent mode on Next.js production apps, and the results seem highly promising, to say the least. So we've just covered a lot of different features and optimizations, and only did that at a very high level. So here's a summary of most of the things we at Chrome have been landing or will be landing soon in Next.js, with some links in case you'd like to learn more or find out exactly which version of Next.js these features can be used. Like Shubhie mentioned earlier, we've been continuously testing and measuring every single optimization we work on before shipping it by default in Next.js. Much of our core focus has been to improve Web Vital scores, especially paint times like first and largest contentful paint. Now, all of these numbers are from example sites and partners that we've been working with closely just in order to verify the impact of each of our optimizations. One of the core visions of Chrome moving forward is understanding that developers feel empowered to choose the tools that give them the best developer experience possible, while also knowing that they can get great user experience to achieve their goals. We think Next.js is well situated in the React ecosystem to do exactly this. And we have plans to continue to apply all the learnings we've learned and to take it to every other major framework used by developers today. We hope you enjoyed listening as much as we enjoyed giving this presentation. Thank you.